Talking Industry, topical debate from the worlds of automation, manufacturing and engineering. Brought to you by DFA Manufacturing Media.
Good morning, everybody. So we're going to be making a start now. I'm John Arkunja. I'm a professor at Cranfield University. And today we're going to talk about Maintenance 4.0. And we've got a really nice set of people here going to be discussing this topic. But firstly, I'd just like to say it's really nice to see you all in person rather than another Teams screen. Today what we've got is we're going to have a discussion. So we've got just some introductions, some quick kind of intros to different topics related to asset management, and we really want to get you all involved in a discussion, and we want to see what does the future really look like. So we've got a lot of experience here in the panel, and we want to really have a detailed discussion on what are the challenges today and where are we going in terms of the digital technologies that are out there. So we're going to have some experiences shared. There's different kind of areas we're going to look at. We're also going to have a discussion about what Industry 4 or Maintenance 4.0 means, really, because I think there's a lot of debate what the scope is and how far we can go with it. So with that, I think I'll just make a very, very quick introduction with digital and with Industry 4.0 and how it's applied to maintenance. I think we need to look at this in a very holistic way. So the whole journey, whether it's how we accumulate data, how we use data, how we actually start to make some impact. So, maybe, yeah. Oh, yeah. So we need to look at this in a holistic way. So the use of digital technologies, they're all enablers. We shouldn't consider them as targets. We need to sort of look at how we can apply them in a way that we get benefits. So we need to think of the potential areas of applications, but look at also, thank you. So we also need to look at how they can be applied to make an impact. So with that, I think let's make a start with the introductions, maybe with Daniel.
Hello. Hi, I'm Daniel Fern. I'm the country manager for Ixon Cloud. Ixon Cloud are a company who work with OEMs, machine builders, system integrators, and we help them with a complete suite of tools for remote service, analytics, and maintenance. So yeah, hopefully I can provide a bit of insight into the OEM world today.
Thank you. And Matt, please.
Good morning. Matt Grogan from SPM, technical sales engineer. SPM are a company that have been in the realms of condition monitoring for 50 years now, involved in developing software, instrumentation, sensors and techniques. So we've fully embraced the Industry 4.0 and automation by making data available. Okay.
My name's Keith Gallant from Reliability Maintenance Solutions, or better known as RMS. In the industry of condition monitoring, we help companies to improve their programs or initiate a program in condition monitoring. So we do that through training and practicing, supporting people on site.
Great, thank you. So the way we're going to run this session is we're going to have sort of up to 5-minute presentations from each of the speakers, and then we're going to have an open discussion. So maybe Daniel, would you like to start?
Don't worry, there's no PowerPoint today. It's okay. So as I mentioned in my introduction, Ixon, we're very focused on OEMs, on machine builders. So kind of my perspective is from that side of things. And I'm going to start with a bit of a controversial statement. And one of the things that we hear a lot in the industry is that the cloud is not safe, that actually machines shouldn't be connected to the cloud. You know, there's a lot of danger out there with hackers and malware and stuff like that. But actually, we honestly believe that the connected machine is actually the safest machine. And the reasons for that, if you think back to 2017, 2018, you think back to what happened with the NHS with the WannaCry attack. That happened because the software the XP-based machines and XP-based systems in the NHS were not secure. They were not up to date. They were not patched. Think about that from a machine perspective. You buy a machine today in 2022. Windows 10 goes out of spec in 2025. Believe it or not. Who's on Windows 11 yet? One person. One person's on Windows 11. So if you think about it from a machine perspective, the software is going to go out of date pretty quickly. And if you don't have a connected machine, who's updating that software? What if your OEM can connect to your machine? They can keep it secure, they can keep it safe, they can keep it patched. That is really, really important, and it's kind of a topic that maybe isn't thought about enough. People think, oh, let's just buy a machine, we'll put it on the corporate network, we don't need any outside connections. And that might be fine for a few years, but then let's talk about 2025, and yeah, suddenly there's no more updates for Windows 10 or Linux. It's a few versions out of date, and suddenly you've got an insecure machine sat on your network. And the second that Dave in the office or whoever downloads something from a phishing email or something like that, that's going to spread through the corporate network very quickly. And if your machines are also on that corporate network, well, guess what? All your machines are now infected. So by using something that is actually able to ring-fence machines, even with an outside connection, you've got an ability for an OEM, for the machine builder, to actually continually support you, continually keep that machine up to date. And even when that software is actually out of date, they've still got a firewall in between the corporate network and the machine network. That makes a massive difference. And from a maintenance perspective, well, the worst thing you can do is not have the machine running because it's infected with malware or spyware or whatever that may be. So, and that's not just Windows-based machines. That can be, there's viruses out there for PLCs, for all brands. It is out there. So yeah, keeping things safe and secure and up to date is actually really important. So that's the kind of first point I want to make. And then I think following on from that, when you've got a connected fleet of machines as an OEM, you've got an opportunity to make more money. Simple as that. So a lot of companies out there, a lot of OEMs are still not really making the most of service opportunities, from actually providing maintenance contracts, from providing service packages, and companies want this. End users will pay for this. And what you've got an opportunity to do there is to actually, to be able to provide insight into machines, to be able to provide ongoing support. That could be through spare parts, that could be through monitoring of critical components that are wear and tear parts. Let's say like a Festo air pump as an example. Really simple. It's rated up to 250,000 strokes. How many machine builders right now know how many strokes that machine has run? What if you could get an alert, a notification, be told that pump needs changing in 20,000 cycles? That eliminates any kind of downtime for that machine because you've got a planned kind of maintenance cycle. And yeah, that's a really easy way of doing it. And I think maybe these guys will disagree with me in their part, but within machines, there's also a little bit of a thought that you need to plaster your machines with sensors to get any useful information out of it. But actually, a lot of that information, even basic stuff, temperatures or vibration or speeds, motors, health, that kind of stuff, that can all be done through the PLC on its own. And yes, there's definitely times when you need to add additional sensors to a machine, depending on what kind of insight you want to get. But yeah, that kind of basic information is already available in the PLC. Why not use it? Everyone's talking about machine learning. Why not just learn from your machines to begin with? Just a thought.
Thank you. Thank you very much. So we'll keep the questions for after all the presentations, so please don't forget them. We'll continue with Matt, please.
Okay, good morning. On a slightly different tack from our systems, we tend to be starting from the standpoint of looking for high quality data first and foremost, and then taking that high quality data and giving ourselves smart data from that, which we can use to determine machine condition. And all the rage is machine learning and so on. from our standpoint, yeah, that's great, let's do that. But in the meantime, you know, let's perhaps use tried and tested systems, algorithms that are already developed to give you accurate machine data, machine information. And that can be broken down into numerous things. You know, it can be down to component level, it can be, you know, just a simple trend. You know, and majority of systems today are moving towards this machine learning and artificial intelligence. You know, but it is going to be a process where we move to that, and it is something that's going to be sort of ongoing. You know, and it's going to factor in as a big part of maintenance going forward. From that end, you know, we've made our systems, you know, more open than most. So all the data that you can collect can be integrated into the systems. A big part of condition monitoring is being able to benchmark that condition monitoring data and to determine whether your system is, you know, basically, providing, you know, the information that it should, that it's working for you. You know, so that's a big part of where we see things moving forward. You know, you may not necessarily wish to see spectrums, time signals, and all that kind of data, but you may wish to see, you know, is this system working for me? You know, are things improving? So I see things moving, you know, further in that direction. So, but yeah, okay.
Thank you.
Thank you very much. We'll continue. Now we've got a video. We'll just share the...
So I am just to discuss initially similar sort of vibes from Matt and Daniel there, where really we need to know our machines and we also need to measure them really accurately, and the importance of that is paramount. So knowing about the machine, we have a real passion for trying to understand the machine, the modes of failure. So how does the machine move through its modes towards a failure? Where can we sense those modes as it fails, and what technology is appropriate? That's really important when selecting the different sensors you can put on a machine. It's not always the same sensor, and also the quality of that sensor to get that high quality data. And I have got a couple of videos here just to show that from a vibration perspective when measuring vibration on a machine and selecting your accelerometer. So I think if we just tap through, there we go. So this is a time waveform from a machine that's the same point. It's actually using the same complete sensor housing with two sensors in it. One is a high frequency sensor and one's a low frequency sensor. So from the time waveform we build the FFT, and that gives us the frequency spectrum. And as you can see on the top one, we're going up to 5,000 Hertz, so 5 kilohertz. On the bottom one on the right there, you can see the data that we miss by only measuring up to 5 kilohertz, because beyond there, up to 10 kilohertz in that measurement, you can see there's a lot more information about the machine, and we can learn a lot more about the machine's health if we measure accurately all the way up to that frequency range. So out there right now, there are sensors that will only even measure up to 1,000 Hertz, 1 kilohertz, where the red dotted line is. So you can really get a feel there for the difference of quality depending on the sensor you put in there. So that's just giving you a comparison really of just 3 different types of wireless sensors for Industry 4 that are out there on the market at the moment. So that second point of the collection of data is important. Oh, sound. This here is from the drive end of the motor, a traditional sensor, very close to the bearing, which is what we encourage, to be as close to that bearing. And you can see we're getting there nearly 20 Gs peak to peak. So we've got a nice measurement from that, lots of amplitude data in there. From the centre of the motor, almost nothing. So if I go and put my IoT sensor in the middle of the motor, I'm not going to get the response from the bearings where the failure modes for bearing problems are. And we're going to see the same again for the frequency spectrum. In a second it'll just pop along. Is that on repeat maybe? Let's see if it goes through. There we go. So there's the frequency spectrum. Some high frequency data, really important to see that. That's where the problem is. If I take it from the middle of the motor, all gone. So if I'm trying to find out about the fault on that machine and I put my sensor in the middle of it, I'm not going to get that information. I'm not going to learn about it, and it's going to fail unexpectedly, no matter how many times we try and take data from it. We've got to get a good quality sensor in the right place.
Great, thank you very much. So I guess listening to all the talks, you can see there's an emphasis on data. What are we doing with data? What are we trying to kind of improve in terms of our insights? And how can we become more proactive in many ways so that we're actually addressing the needs of the future, potentially without compromising the performance of the assets? So with that, I have some questions in mind, but I'd like to maybe let the audience ask any questions you have in mind. Please.
You have 2 questions to start off. Thank you very much. Okay, lots to talk about data. Who owns the data? So sort of
The customer.
Okay. Is that the same for everyone?
In our opinion.
Yeah. Same answer for.
Yeah, absolutely.
Okay.
So in Ixon Cloud, the data is owned by yourselves. So every company has their own kind of siloed part of data, and you're of course free to export that or put that into a different system. You know, you might want to export that into like Power BI or build something in Azure, your own kind of modeling, Tableau and stuff. You know, real deep data kind of solutions. Yeah, absolutely. The data, the data belongs to you, and that's really important because if you're tied into kind of a contract or something, and they've got your data held to ransom. Yeah, that's also not a great situation to be in. So yeah, absolutely. I think that's a good question and one to always bear in mind when you're choosing a solution and looking for, yeah, the right thing to work with.
Okay, thank you. And if I may, another part. So on that frequency spectrum there, that's very good. And obviously there was a lot missing when you cut it off at just a kilohertz. So I can see that there is more data there. Does that translate into being able to do more? So if I'm thinking of cheaper sensors, less data, less processing power is needed if you're only looking at a smaller amount. And I think in the case of some of our equipment, you know, we've only got very limited sensors in there already. Can you still get some information out, like with the harmonic frequencies? You know, if something was happening at 10 kilohertz, would it also be showing up at 5, 2.5, and 1.25 that you might be able to pick up, or is it directly proportional that 3 times as much spectrum gives you 3 times as much the capability to diagnose? Is there that link?
Yeah, it's a fair point. So it depends, as I was saying, on the failure mode. So different failure modes will respond differently with different frequencies and where those amplitudes in the frequency range. So if you've got, say for instance, bearing defect harmonics, it's not common that the first harmonic will be the highest amplitude. It's usually 2, 3, 4 orders where you start to see the increase in amplitude, and obviously the amplitude is relative to damage. So if we're not measuring up that frequency range, we won't understand the severity, and it's always severity that's most important when we're doing in terms of vibration, the condition monitoring, because the first question that the client's going to say is, when's it going to fail? And we can only tell that once we know the severity, and also using the trend data to see how severe that is increasing as well.
So it's not as easy as kind of 3 times, but it's about the insights. What decisions are you trying to make? So you need to be very purposeful, very targeted in terms of how you're going to use that.
I think that's a really important point as well, actually, about what is it you want to do. So we work with a lot of clients who say, yeah, we want to do something with data. Okay, we want to do machine learning. Okay, have you started collecting data? No. Okay, well, how do you plan to do machine learning? What do you want to learn? Is there particular parts of the machine that you're seeing constant failures on? Is there something you want to improve? Is there something you want to de-spec because it's the most important part, and actually you're over-speccing a motor or something similar? Well, without that data to be able to prove that, you don't know. But I think almost sometimes you need to start at the end, work out what it is you want to learn, and then figure out the path to get there through the various solutions that we have on the market. So I think it's a good point.
I think one of the big challenges I see is, how do we define demand for the asset? Because supply, we can plan that. We're probably really good, much better at planning for supply. But if we don't know the demand, If a customer says, I need just 60% availability of the asset, and you're planning to deliver 90% availability with all this tracking, you're wasting money. So it's really key. Any other questions, comments, please?
Could I just make just a couple of points in relation to your question? Where we'd sort of look at it would be from the perspective of, machine criticality, what is your most critical machinery, and also, pre-warning time as well, is the monitoring method that you're actually using, is it going to indicate a fault, as early as possible? And that's what you would really want, and again, sort of high quality data, pre-warning time, certainly for your most critical machinery, your plant stoppers and so on. And in that way, I think you can make a delineation between two different types of systems. You may have sort of more basic systems that you might say for, more straightforward plant that maybe doesn't, maybe is criticality C or D rather than A or B. So just as a point, that's really good.
Thank you. Good. Any other comments, please? Did you have your hand up? Okay. Thanks, please.
Morning, gents. Adam Hall, Malvern Panalytical. Just take this in a slightly different direction. Road to net zero. Do you see any demand, or are you hearing of any demand for people to use these sort of systems, not necessarily to predict downtime, but to optimise machines and maybe take it a step further and prove that they've optimise a process or optimise a system?
I would say just over the over a number of years, people have talked about precision maintenance, being proactive, alignment, balancing, lubrication, and I think that really has always been a big part of predictive maintenance and condition monitoring. So from that end, I would say yes, because it's certainly now it's more important with the cost of energy, that our machines are, we're sort of, in a good place or optimised, as you say. Yeah. So.
Yeah, I think that I agree with that, and the point Matt made at the beginning there's a road to get there first, and a lot of companies are still on that journey, learning those precision techniques, learning how to make the systems more reliable. When they're more reliable, then you can start to look at how we can make them more efficient.
Yeah, I think downtime is obviously the key word in the industry. Everyone hates downtime, right? You hear downtime and you run around screaming and shouting and panicking. I think what's really important is that you also need to understand what's going right as well. So think about it from uptime. What's the uptime, not the downtime? That's a good way to start. And yeah, especially at the moment, you say energy costs. Any small efficiency gains you can make on it, even on one asset in a factory. You're talking about 2%, 3%, 5% efficiency on production, either on the output or on less wasted energy or less wasted units that are produced, less returns, rejects, that kind of stuff. That's massive, and the waste is also a massive part of that. And getting to this net zero kind of thought, you need to cut down wastage as much as you can. And I think predictive maintenance and condition monitoring is a really key part of that, to make those small incremental steps of cutting out silly mistakes or silly things that can be avoided. So yeah, I think important. Yeah.
I guess from a research perspective, what we're seeing, there's two main trends. One is looking at how do you trade off between carbon and commercial gains. So those kind of tools are missing at the moment. So that's one thing, because it shouldn't be, well, I think the perception in industry is you don't want to lose the commercial opportunities. So we need to do that hand in hand. But how do we do that? I think that's one challenge. But the second, I think, perspective is probably that efficiency gains is probably the best way to get environmental impact. I think that's the kind of approach at the moment. But I don't think that's going to be strategically the fundamental change in how we do things. I think we need to look at, do we need an asset? Let's start from that and work backwards, rather than look at, we've got the asset, let's improve efficiency, because the scale of improvement won't be the same. Any other comments, please? Any questions, please?
Thank you, John. Just a comment on data and ownership. What's the situation when the data is held in a different jurisdiction, for example, the European Union or United States, and the customer is elsewhere, such as in the UK?
I think for the most part it comes down to the terms and conditions of that individual company. I know as an example, with our company, data is held in Frankfurt, which is generally regarded as the kind of data capital of Europe. But every solution is different, and yeah, again, maybe there is thoughts, or you should be thinking about that when you're choosing a solution if it's important. However, I think most terms and conditions are, pretty kind pretty understanding in that is a thought to people as well. So I don't know the actual ins and outs of it myself in terms of what the differences are between countries, but I don't know much more than that, to be honest with you.
Yeah, a little bit the same. I guess it depends on the jurisdiction. The only I guess comment really would be, it's nice to have a choice between sort of maybe having data internally, and also in the cloud as well, so that you can keep it within the organisation. But yeah, we've always gone from the standpoint of, it is the customer's data, and they may wish to keep it completely, within house, even with the wired systems and integrated into other platforms. So that's kind of where we are with that one.
My other question was just whether you could draw any distinction between legacy equipment and new equipment in terms of monitoring it for maintenance purposes. What would be the differences?
Would you say in terms of sort of machine condition, or how
you would approach
learning?
it? I mean, presumably newer equipment would have more things on board, which you might want to interface to get better data, or you might not need to. Whereas, there's a lot of equipment out there, as I think somebody says, 20 or 30 years old. And you need to add devices to it to get the same information.
Yeah, so if you're talking from sort of machines, as in assets, then obviously there's the standards, vibration standards and so on, and SPM. We do have a number of techniques, that sort of give you accurate, machine condition information, but and you can establish your own baselines and so on. If I've understood your question correctly. So.
Yeah, I was going to say, it comes back to the other question about net zero, reaching those targets. We've, just out of experience we've had with a customer, the policy was changing, corporate policy, to improve any motors must be changed to the latest IEC rating, so they're more energy efficient. But that would also mean they're moving from cast iron motors to aluminium motors, and that's fine in a net zero sense, but the dynamics of the machine then change dramatically because you've changed the mass that's on the machine. That can incur more problems. That's cost and time, obviously, repair problems, and getting to the bottom of it. When in reality as well, by maintaining old machinery, it's better for the environment because we're not producing more copper out of a mine, we're not producing more paint to go on the machine and so on. So if we can monitor our legacy machines better, understand them better and look after them and care for them, then that's much better for net zero going forward.
Thank you.
Good. We have another question over here.
Hiya. It's another one on data, so sorry. With all these different companies doing condition-based maintenance, and I'm sure more and more companies will do it, it seems a shame there's not like an open database for all of that data to go into, to all learn from, and especially going to net zero. You can benchmark yourself and your assets against other companies. Is there a view of doing that in the future, do you think?
I haven't seen an open source sort of thing. As analysts, we do try and share information to understand machines through events like this and seminars and so on. But personally, I think there's a great opportunity from the financial markets to create some indexing based on reliability of machinery, and then to rank those companies, Fortune 500, all those, FTSE, based on how well they perform at plant reliability level, because that will drive their motivation to keep their top line.
I also think from an OEM perspective, this is starting to happen a little bit more. So we've now got customers with fleets of maybe 100, 200, 500 machines out in the field with kind of modern PLC systems where they can track basic information just through the PLC without needing additional sensors or adding other things in too. Once you've got 10 machines, you've then got a benchmark of their performance, and if you're building series machines, you can then put all that data into something like Power BI or Tableau. Again, I keep mentioning those are really powerful tools for this type of stuff, and benchmarking against your own machines. I think there may be a case that if you're benchmarking against equipment, not the responsibility of an OEM to be able to do that and provide that service, and even proactively tell people, hey, we can see your machine is running 10% lower than the rest of these machines, or what would benchmark out the rest of our fleet. Do you want us to come in and take a look at it for you? And again, that relates back to my point on stage, is about business models, proactive customer service, customer experience, and that's got to be driven from an OEM. So yeah, interesting question.
Yeah, it's certainly a great idea, and I think most systems worth the salt now are able to sort of export data, get data out, and even if it's just a simple aggregation of overall vibration for a particular type of machine, just a velocity measurement, something like that. Now, just picking up your point about OEMs, whether that's the kind of thing that they'd want to share sort of from themselves, I don't know. But I guess that would be a case of OEMs being, sort of speaking with each other or within certain organisations. But certainly, yeah, it is a good idea. Yeah.
Good, thank you. Thanks for that. Any other, please?
Another question, if that's okay. The first one, in terms of general equipment, maybe rotating machinery, but things in general, is there a rule of thumb of how many sensors you need in order to do meaningful diagnostics? So, is there a case that there's one killer sensor that you can put on, the vibration sensor or something that does practically everything, or do you find you need 3 or 4? And then is there a diminishing returns as if you add 5, 6, 10, 20 sensors on, you're not really improving?
As vibration analysts, we'd say you can never have enough, But yeah, I mean, I would say, if you're monitoring a machine online, then every bearing point, at least, if you're collecting data from that, and okay, you could swamp the machine, with 3 sensors on every measuring point, or triaxial sensors. A lot of wireless sensors now are triaxial MEMS sensors because it's very cheap to be able to do that. So that does give you a lot more information, and then obviously combinations of, vibration, temperature, and so on. But yeah, if you can collect as much data as possible, that's great. But as you say, diminishing returns, But I mean, just one point really, I suppose. As we're moving, we see people moving more from, portable data collection to, fitting wireless sensors and data being transmitted maybe 4 times a day, as opposed to maybe once a month. That's probably, the best thing moving forward, I would say. And it's, you're flagging something, you're seeing a change, whether that's horizontally, vertically, axially, you should be able to pick up a change, from where you were.
Okay.
Oh, sorry, I'm going to say, yeah, on terms of the IoT sort of wireless types of sensors you put on there, and like we're saying, we like to see them at each bearing point, when we're talking in vibration and temperature from those. When you get more data like that, and you start to see more often, when you see more data points, you start to see more about the machine, learn more about the machine's behaviour through different events than you would normally see by a month-to-month or a fortnightly reading, because you're getting it so frequently, the data. And that can be things like what happens when somebody lubricates. You can see the temperature go up in real time, and you can see it come down as it settles. And that's a great insight for us as condition monitoring engineers.
Okay, thanks very much. And if I may, you kind of alluded to the holy grail being able to say this component is going to fail at this exact time and date. Kind of how close do you get, or does industry get in general, about being able to do that predictive diagnostics? How far in advance can you predict, and kind of with what accuracy? Is sort of 80% good? Is 95% good? What can you do in terms of the what's going to fail, when it's going to fail?
Do you want to go first? Yeah, yeah, that's it. I mean, an old adage within condition monitoring is, we don't provide crystal balls. We provide monitoring equipment. But if you're monitoring a machine and from new installation, you're looking at changes, you can get a pretty good indication. I should mention that our own company, we have a method for monitoring rolling element bearings. Right from from inception. Shaft diameter, speed, gives you a green, amber, red. When you're in the red, it's giving you it should be changed. So that's probably the best answer I can give.
For me, it feels like there's too many variables. So real world examples, forklift truck reverses into a fan, it fails a day later. Nobody monitored it in between those times. And if you add some IoT sensors on there, probably could have smashed off, and you've got no measurement data coming in. Another real-world example on a paper machine that's recently put IoT sensors on all their bearings. One of the operators, struggling with something, removed the sensor and stuck it onto a panel next to the machine, and then the bearing fails, which is so typical. It's going to happen on that bearing, and that's the difficulty of trying to predict when something's going to fail. Is you don't know the other variables that are just unexpected.
I think, also from an OEM perspective, it's what I do, but it really depends on the type of machinery you're looking at as well. So we're talking about bearings and stuff here with these guys, but it could be as simple as a temperature, and you're seeing a temperature on a certain component or a certain drive or certain whatever that may be, slowly creeping up over a week or a month or a year or whatever that may be. But you've got to have that trending information to begin with to be able to find that. And perhaps then you can use a system for notifications internally or to the OEM or to whoever that is, who can call you and say, yeah, that doesn't look right to us, that should never be above 80 degrees or whatever that may be. And that could be on anything. It doesn't have to be a drive, it could be a particular sensor or oil level, all the common things that are going to cause failures. And that's pretty simple to do, especially on modern machinery, PLC-based machines, which most are nowadays. That information's generally already available in the PLC. You've just got to use it and interpret it and monitor it. It's there. It's already there. It's just a case of how do we get to it, how do we use it, how do we interpret it, and turn that into an actual tangible alert or something that someone can act on. It's all well and good having all this information, but if no one's acting on it, there's no point.
So you're not going to be in a situation where the computer says this day there's a failure. You need to interpret it and sort of put it into context. Yeah. Sorry, did someone? Good, please.
Thank you. In terms of interpretation, are we anywhere near being able to interpret, are customers anywhere near being able to interpret vibration data by themselves, or do you see a world for quite a long time where we need analysts interpreting and making decisions, or at least advising on those points?
I guess it's a little bit, not quite an answer yes and no. A lot of smart systems now, are able to interpret, give you possibilities on, problems, do, the diagnosis if some information's known on the machinery. But to a certain extent, it still needs an analyst to look at that. But I think, as time moves on, as more data is collected, as systems become more complex, then we probably will move towards that. Yeah, but yeah, so it's a bit of both. At the moment, certainly from different levels of monitoring. If we're looking at frontline condition monitoring, if we're looking at overall trends, they can be always interpreted very easily by the layperson. If we see a trend increasing, if it's moving from green into amber into red, that gives you an indication that something's changed, and then it should be followed up. So But yeah, I think for the foreseeable future, we're always going to need analysts for a certain extent. Yeah.
I think you've hit on one of the main things that we would have liked to have discussed with giving more time in presentations, and Daniel as well, is who's going to look at that data. And if there's so much of it, and we're using analytics engines to have that first glance, that's a great way. If we can teach them well enough to give us a heads up, something's wrong, something's changed, a person needs to go and look at it, a specialist. And I went into a site recently, and they had sensors on all sorts of machines, vibration sensors, that I would never normally go and put sensors on because of the way they run. And they were just trending the data, and the engineers could see what the trends looked like, and if they saw a change, it was, can we have the specialist in? So they bring in a specialist with a much more in-depth analyzer, goes and takes all sorts of different types of readings, different types of tests that you need to do to understand the problem, and I think that's where we're at in terms of who's looking at the data. Yeah.
Good, thank you for that. We have another question here.
Hi, I just want to ask, what do you think is the best approach for the condition monitoring of a piece of equipment that is used for different processes or different applications? I'm imagining a situation where the trending of your data is made more complicated by the changing of background conditions, and especially when you have poor visibility on the change of this background condition. So what would be your approach, and what do you think is the ability to actually understand the failure of this piece of equipment?
Yeah, the first rule, or one of the first rules of condition monitoring is, you need repeatable data, and it needs to be in the, the same condition. So, so that you compare like with like, if you will, so that you can make a diagnosis. That can be done by filtering of data. So you may sort of throw data away which doesn't meet certain criteria. So you may say, well, I want this particular machine to measure the speed at X, load at X, so underload, speed, possibly temperature. The only reason being is that if you can meet all of those conditions, you can then whittle away the data that you don't need and get some repeatability. So I was racking my brains trying to find another parameter, and one might be, say, current or something like that, where we can meet all these different parameters.
Yeah, no, what he said, that's good.
Good. Are there any other questions? I sort of want to move the discussion a bit towards what the future looks like. So how do you see the future in terms of asset management?
Yeah, as we're all about Industry 4.0 and connected machines, we see it's going to move more and more that way, where remote machines, machines in the city, smart cities, that kind of thing, as we're moving, down that sort of nexus, connectivity becoming more and more, it's going to become more and more to the fore. Sensors will become cheaper, and these systems will become much cheaper, and I think they'll be a lot more automated than there is now. So I just see more machines online and connected. Is the short answer.
Yeah, from my experience, it's similar. So when I joined Ixon 4 years or so ago now, there was not many companies in the UK that were actually even installing connectivity options on the machinery for remote support or for remote analytics. I'd say that's probably 75% of OEMs are now doing that, at least in some format. So I think companies are beginning to realize that there is real value in data, that it can actually enable them to have kind of better relationships with customers past the initial sale of the machine, because it gives them a reason to stay in contact, it gives them a touch point, and it also allows them to, as I mentioned before, sell additional warranty periods, service contracts, where they are the experts on their machine. They know what the machine should be running at, and they can go away and actually utilize that. So there's a big piece at the moment about working out business models, about working out how to maybe monetize data and that analytics as an OEM, instead of passing it to a plant and then trying to do something afterwards. So I think we're getting there. I think we're still a few years behind the Netherlands, Belgium, Germany, in honesty, and from what I can see in the OEM world, where those companies are already starting to look at machine learning. But again, we get calls saying, hey, we want to do machine learning. Okay, where's your data coming from? Where's your year's worth of data to benchmark against? Oh, we don't have it. Or how are you going to do machine learning? So I think that message is starting to get out there. I think if we sit here again in 2 years, hopefully, all being well, then I think the topic will have moved on quite a bit, and I'd like to say that OEMs especially are taking that opportunity to do that, if I'm doing my job right.
Yeah, so I think there's a danger of the future where we oversimplify how complex problems with machinery, how complex problems with machines can be. And through better education, people can understand the problems and then understand how to rectify them and what sort of technologies that need to be used, ways of implementation. And it really starts with that education, and I think that's in the future. We're seeing more and more now ways to educate people on reliability, the technologies, the theory, the management levels within businesses. So I think that's a really important future as part of it.
I think it's still quite scary from talks I have with some customers, even end users, on how many machines are ran to failure. It's absolutely crazy how many times that happens where people have no insight, and it's just, yeah, we just run it and then it's broken. It's like, so even getting that first stage of being scheduled maintenance is a first step, and then you start thinking about predictive or react. Instead of being fully reactive and waiting for things to fail, there's also got to be a mindset change of end users in that, this is a serious topic. This costs us money. This costs us time. This costs us effort. I think everyone's got a part to play in that education piece, in the equipment that's available, in the solutions that are available, and how easy they are to use. So yeah, again, I hope in 2 years' time it's a bit different.
Good. Any other comments, please?
Hi, Jonathan Williams, Zerini. You mentioned, you've been speaking a lot about the micro condition monitoring, so the condition monitoring of individual components. But I think, and looking to the future, we're going to be moving from that with machine learning to a more macro. So where in the whole plant or assets, how those components interact or operate in the same environment together, along with all the environmental factors that are going on, and so looking at failures from not just an individual thing, but all that data, mixing it all together to get a macro view, a macro level. So what's your do you think it's also going to be moving in that direction?
Yeah, so one of our customers has got that sort of system in place now, where you go to their office, they've got a screen right up to the ceiling, as wide as you like, and it's got data coming in from assets all around the world, and it's that macro data, and they're using analytics engines to understand where they need to go and focus their energies, and that's already happening. Yeah, it's good to see.
I think it really depends who is, the organization. If it's the likes of a large OEM, they're interested in the factory. If, for example, I'm a large aerospace service provider, I'm looking at the fleet. I want to be able to manage gearboxes across many assets. So in that kind of context, I do want to correlate data across different assets and become much more proactive in planning that. So I think it really depends. If I'm an SME, maybe I'm in charge or responsible of the particular part. I don't have visibility of the whole factory. It depends on contracts. It depends on how your revenue flow is. But I think moving forward, definitely, it's much more holistic, much more how different parts or subsystems or kind of systems are connecting with each other. I think for the future, it's really looking at that much more and potentially improving the predictability at component level as well, kind of going bottom up and top down, that kind of balance, so that we can plan much better. Any other comments or questions, please? Are there any technologies that we should be looking out for much more moving into the future? I know we've talked a lot about condition-based maintenance, but in terms of asset management, widely speaking,
I think the camera sensor, I mean, some of my colleagues here are going to laugh because I'm going to bring this up, but the camera sensor is the sensor of the future. And the amount of information we can get from a CMOS sensor now is enabling amazing technologies to be developed. One of those, motion amplification, which I use a lot of, allows us to visualize the vibration on a machine rather than just measure it and look in a graph. You can actually just see it in the video. So things like that, I think, are really going to change the way that we start to sense machines using different sensors.
Good. Any other suggestions?
Yeah, I would just say, as an organisation, SPM have always continued to innovate new techniques. So it's not always just about developing new hardware, but new techniques to better monitor slow-speed machines, for example, or tricky applications. So yeah.
Good. So I mean, I think it's really about the whole journey, from where you get the data to, even before that, look at why you need the data. What decisions are you trying to make? Commercially, if you haven't already got the ROI, you shouldn't be investing in the technology. So it's as simple as that. But the whole journey is the data has a purpose. You're then modeling it, using it in some shape or form. And then you need to think about the interaction in terms of how people are going to make decisions. I've seen many places where you've got this fantastic model. It's producing these amazing results, but you've got 3 or 4 people looking at the data and interpreting different things. So how do you deal with that? The visualization is also key. So that whole journey needs to come together as we move into the future. So I'm conscious of time. Maybe just 1 minute, last comments from the speakers, please. So future of asset management, how do you see it?
Yeah, as we mentioned before, more connected machines, smart data, high quality data, just more online systems, really.
Great, thank you.
I think more kind of harmonious communications, so using protocols like OPC UA will become more and more standard in the coming kind of years. Instead of having 20 different types of Modbus or OPC UA, etc., we'll have maybe start to narrow down to one kind of common data protocol, which will help. It'll help with technologies like sensors, because they'll all be streamlined to one particular technology. It'll help with PLCs. And I think that journey along there will also, it's down to OEMs, it's down to the equipment manufacturers to utilize, interpret, and use at the end of the day. So, yeah.
Perfect, thank you.
So I'll leave you with my favourite condition monitoring statistic, which is a well-established statistic that 80% of all equipment failures is random in nature. So it really just highlights how much we need to understand our machines, what the failure modes are, and monitor them.
That's great, thank you. So I think we'll probably wrap it up now. Thanks all for joining.